So for today's lesson, we want to practice combining like terms and using the distributive property. Combining like terms is much like adding and subtracting integers, where if the signs are the same, you add the numbers and you keep the sign. If they're different, you subtract, take the sign of the larger number. But they have variables on with them, okay, in some cases. So let's go ahead and get started. So when it says combine like terms, the first thing we need to know is what is a term? A term can be a number, and I have that over here, for example. That's an example of a term. And it doesn't just have to be positive. It can also be a negative number. Okay. It can be a variable. And here I have a variable. Doesn't have to be the variable X, any variable, any letter. We all know that's what a variable means. It's just a letter. And I didn't put this, but it can also be a combination of variables and numbers put together where it's multiplication. So like right here, that's a term because it's a combination mush or smush together, okay? 2x, negative 4x squared, they can have exponents on them. That's a term. 5x cubed y, that's a term. So it could be a number or a variable or a combination of numbers and variables mashed together. And it says they're added or subtracted in an expression. So terms are going to be separated by plus or minus signs. And you'll see that. Let me go down here. So look at your practice problems. So like number 1, I'm going to draw little spaces. Little bars like we did on adding and subtracting integers. Before every plus or minus sign, you can draw a little bar. But I can see that this has one term. This is a second term. This is a third term. That's a fourth term. And that is a fifth term. This one has 5 terms. But this one only has 1, 2, 3, 4 terms. You see, and then we'll take a look at this one. This one has 1, 2, 3, 4, 5 terms. Okay, so some of them may only have 2 terms. If I wrote something like this, that's only 1, 2 terms. But at any rate, terms are separated by plus or minus signs, okay? And you didn't have to draw any of that, but I just want you to know that terms are separated by plus or minus signs. All right, let's take a look at like terms. Like terms are terms that have the same variable with the same exponent. So for instance, these are like, they both have the variable x, and the x both of the x's have the exponent of 2. That little number up there is called an exponent, okay? And I wrote a little note like this is 5 to the third power. So that little 3 is your exponent. Or this is x to the second power. That little 2 is your exponent. So the little numbers at the top are your exponents. I don't know if you all discussed that in 6th grade or not, but I know you discussed it in my room. So if you got on Google Meet or you're in my class, you know that. It says, I'm going to go right here. Numbers, regular numbers, are also like terms, like negative 4 and 10. 5xy and 3xy are like terms. Even if you see something like this, they're like terms because you got m squared and m squared n. You got an m with an exponent of 2 and an m with an exponent of 2 and an n. Okay? But don't get mixed up because if you see something like this, these are not like terms. These two aren't. Because this is an m and this n has an exponent of 2. But this, oh, hold on, that's not what I wanted to write. Hold on, take that off. So this is an M with an N with an exponent of 2. This is an M with an exponent of 2 and an N with no exponent, which is an understood 1. So this is M squared. This is N squared, and that's N. They're not the same. So they don't have the same exponent above each letter. So they're not like terms. If that doesn't make sense to you, make sure you pause the video and let me know. But these two are like terms. I was about to spell that wrong. Because you got M squared N, M squared N. Okay, let's talk about a constant. A constant is just a number. When I say a number, I mean a regular number. So for instance, -4 and 10, they're regular numbers. They're also called constants. Constants are always going to be like each other. They're like terms. So these two, like I said, that's why I could say these two are like terms, because they're both two constants, two regular numbers. All right, so let's take a look at this. Let's just shade the like terms the same color, y'all. Hold on. All right, we're going to shade the like terms the same color. So let's just go through and pick out something. Let's pick out green. And hopefully it won't be too dark. Okay, that's good. All right, so -3x squared. Trying to get this to shade all the way. Oh, there we go. -3x squared is like what else? Okay, it's like x squared. It's also like -5x squared. I'm just finding the terms that have the x squared on them. Anything else have x squared in this chart? No, nothing else has x squared. So all those are like. And let me go over something else too. One other thing. Add this to your notes. A coefficient. A coefficient is a number attached to a variable. So if I have 3a, 3 is the coefficient. Or if I have 7x, 7 is the coefficient. If I have -2y, -2 is the coefficient. And just a number in front of a variable. So like here the coefficient is -3. Here the coefficient is an imaginary 1. Here the coefficient is -5. But to determine like terms, we just got to make sure they have the same variable and the same exponent. Okay, let's take a look at this. You know what I'm going to do? Instead of shading them, because that's not working out, instead of shading them, I'm going to circle them in a certain color. So -3x squared was like x squared and -5x squared. Yeah, that's much easier. 8x, find anything else with just an x. No xy, no x squared, just x. Would be like 25x, -2x, 67x, 90x. Okay? All of them have x's. Now the coefficients are different, but all of them have just a regular x. So they're all like. All right, 6. 6 is a regular number. So what is it like? It's like 15 because 15 is a regular number. 0 is a regular number. -3 is a regular number. -1 is a regular number. 7 is a regular number. So they're all like. Okay. Let's look at -4xy. Well, what has an x and a y behind it? Well, -10xy, 22xy, 50xy. Now I have some other things that are not circled on this chart, so let's take a look at those. I'm doing them in green. Okay, 9y is not circled. Okay, I see 75y, and I think that's it, because the rest of them are already circled. And so we should understand what like terms look like, guys. All right, so we have some practice problems here. So with the practice problems, we're going to simplify. Simplify means we're going to take this long thing that has multiple terms and make it smaller, or we combine terms. So that's why we say we're going to simplify by combining like terms. Combining like terms make the problem smaller or more concise, shorter. So what you do is you kind of draw a bar after each term. So separate it. And you make sure if it's a term with no coefficient, it has a variable, and you put it. So like this has a variable, but it has no coefficient, so put your 1. This is +1 is a constant, so I'll leave it. Okay, go to the third term. Its coefficient is a 1. The fourth term, its coefficient is a 4. And then +4, the last term, is a constant, so I'll leave it. Remember, coefficients are the numbers that are attached to variables, okay? So if you see a variable and it has no number in front of it, put an imaginary 1. Okay, now what I'm going to do is combine like terms, and I'm going to do these in different colors. So I want to know, what is 1x like? My goodness, get away. Okay, 1x is like 4x. Now you have to apply your integer rules on these. So 1 is positive and +4 is positive. Those are the same, so you just add. So if I put 1x with 4x, I get 5x. Okay? Now, +1 is like the other constant of +4. Both of those are positive. So I add those and get +5. But what about this? It's not like anything. So I just bring it down. And I can put that 1 back there. Now, the order in which you write these doesn't matter, because somebody may have 1x squared plus 5x plus 5 on the paper. I don't care the order in which you put them in. Just get the signs right, the numbers in front of the variables right, the coefficient, the sign of the coefficient correct. Okay, order does not matter. Okay, let's take a look at 2. So after each term, draw a bar. So I see I have 1, 2, 3, 4 terms. Okay, so let's pick out what's like. -4x is like -8x. And both of them have a negative coefficient. So because they're both negative, I add them. So if I add -4 to -8, I get -12. So when I combine them, I end up with -12x, and then I have 2 constants. So I'm going to put my 2 constants together, because constants are like terms. +5 is like -9. 5 is positive, and 9 is negative. But those signs are different. So with different signs, we subtract. So we put the larger number on top, 9 minus 5, and get 4. But it's more negatives than positives, okay? Or the higher number has a negative sign, so I make my answer negative. So I have -12x minus 4. Or I can write this as -4 minus 12x, again, because the order in which you write your answer doesn't matter. All right, let's take a look at the next problem. Draw a line after each term. And if you're concerned about what the terms are right after the plus or minus signs. Okay? Or as soon before you get to a plus or a minus, draw a bar. Right before you get to a plus or minus sign, draw a bar. Okay, what's that like? So I need to look for x squared y. Well, this has x squared y. Now don't choose something like this because this is x y squared, not x squared y. So we don't want to choose that. Just want to look at those two. All right, so this coefficient is -7, but this is an understood +1. It's positive. Okay, those signs are different. So since they're different, we're going to subtract 7 minus 1 is 6, but it's more negative. So it's going to be -6x squared y. You just change this coefficient to -6 when you combine them and put your x squared y back down. Okay, let's look at these two. -2xy squared and then 5xy squared. Those are like, okay, this is negative and this is positive. Well, they're different. I got a -2 and a +5, so I'm going to subtract. 5 minus 2 is 3. But I have more positives this time, so I'm going to leave it as positive. And if I say positive, I'll write a plus. Plus 3xy squared. If I were to say negative, I'll write a minus. Okay? But it's positive. Now, you could have written 3xy squared minus 6x squared y. So again, if you say positive, you can write a plus. If you see negative, you can just write a minus, okay? Let's take a look at this one, number 4. And then we'll move on to the distributive property. Before every plus or minus, draw a bar. So draw a bar before that minus, draw a bar before that plus, draw a bar before that plus, and draw a bar before that plus. Now 5AB is like positive 7AB, and plus negative 11AB is the same as negative 11AB. Okay? All right, so this is positive. That's a +5. That's a +7. That's a -11. I'm going to take these two and add. 5 plus 7 is 12. That's going to be 12AB. But I still have a -11AB. They're different. That's a positive, that's a negative, or you could just say it's regular subtraction, which gives me 1AB. They're different, subtract. You got more positives than negatives, or just 12 minus 11 is 1. And then you have some constants here, okay? So you have the constant -2 and the constant +12. Well, that's negative and that's positive. So they're different. Since they're different, you subtract. Well, what is 12 minus 2? Well, 12 minus 2 is 10. And it's more positives than negatives. So I get a +10. If I say +10, I write +10. Now, let me show you something, guys. Sometimes you won't see this understood coefficient of 1. Sometimes you'll just see AB plus 10. Okay? It'll be like an understood coefficient of 1. You won't see the 1. You could have also written 10 plus AB or 10 plus 1AB. Again, because order doesn't matter. All right, so let's take a look at using the distributive property. Second part of your notes. So usually when it's mashed together, that means multiplication. Well, always, not usually. It means multiplication. This is basically 2 times 3, okay? You can also see it with a dot. but you may also see it with parentheses and it's mashed together. Now, in elementary school, you learn to read this as 2 groups of 3 right before you learn how to multiply. 2 groups of 3. Okay? So if it's 2 groups of 3, I write 2 3s. 3 plus 3 is 6. So I'm going all the way back to elementary school to teach you the distributive property for 7th grade. Similarly, if we have something like this will be 2 groups of, what's in parentheses, x plus 3. So I need 2 groups of x plus 3. So if 2 groups of 3 was 2 3s, 2 groups of x plus 3 is 2 x plus 3s. So here's the first x plus 3, and here's the second x plus 3. But you add them together. You got to put a plus sign between them, okay? Same thing here. The plus sign has to go between them. So there are my 2 groups. First and second group of x plus 3. But you should be able to combine like terms. So before every plus or subtraction sign, put a bar. And the coefficient here is 1. The coefficient here is 1. 1x and 1x are like. So this gives me 2x. And then these constants are like. Plus 3 and plus 3 gives me plus 6. So I know that 2 groups of x plus 3 simply equals 2x plus 6. That's what it equals. Hold on, guys. All right. Here, the next one. I'm sorry, I'm cooking breakfast too. Here you have 3 groups of this stuff, the stuff that's in parentheses, which is x minus 4. So I got 3 groups of x minus 4. So there's my first group of x minus 4 plus a second group of x minus 4 plus a third group of x minus 4. Okay, so that's my 3 groups of x minus 4. Write it out. Then I can combine like terms to see what it is when it's all put together. And I'm going to erase I circle the plus signs, okay? So now I see that that's 1x, that's 1x, and that's 1x. All these are like terms, so I can combine those. 1x plus 1x plus 1x equals 3x. And then I can combine my constants, negative 4, negative 4, negative 4. All of them are negative. So that means I can add them all together. Negative 4 plus negative 4 plus negative 4. That's negative 8. And negative 8 plus negative 4 is negative 12. So that gives me negative 12. Add 3 4s together, you get 12. All of them are negative, so keep the negative, okay? So basically, this means that 3 groups of x minus 4 equals 3x minus 12. That's what that means. Now, you should be able to see a shortcut. Instead of writing out groups, there's a shortcut. So there's a way to get from this straight to that, or there's a way to get from this straight to that. All right, so here's a shortcut. Instead of writing out groups, from now on, what we're going to do, so instead of writing out groups, what we're going to do, the shortcut is to multiply the terms, each term inside the parentheses by the term outside the parentheses. And let me show you what I'm talking about. The term outside the parentheses is 2. But I multiply each of these terms that are on the inside by that 2. Okay? So 2 multiplies x, and that's an understood 1. So 2 times 1x is 2x. And then the 2 multiplies the 3. 2 times 3 is 6. And that's a positive 3, so I put plus 6. So the shortcut is just to multiply. So I still get 2x plus 6, but I don't write out groups. Okay? Multiply the outside term by the inside term, okay? Okay, let's look at here. Look at the next one. What's outside? 3. Multiply by the inside term. 3 times x is 3x. And 3 times negative 4. And I read this as 3 times negative 4. You can use a smiley face. A positive times a negative is a negative. Leaves me at negative 12. Because on multiplication, you use a smiley face, okay? This is not combining like terms. On combining like terms, you use same signs, add and keep, different signs, take the sign to subtract, take the sign of a larger number. But down here, this is multiplication. So whenever you use the distributive property, you can use the rules. Same signs will give you a positive, and different signs will give you a negative, or you could use the smiley face because the distributive property is nothing but multiplication. All right, let's take a look at some more examples, okay? So I got a few more examples and then we'll be through. So I'm going to say 7 times 3x. Well, 7 times 3x is 21x. Now look at this is 7 times negative 1. 7 times negative 1 is negative 7. Positive 7 times negative 1 is negative 7. That's all you do. Here you have negative 3 times 4x. Okay, that will give me negative times a positive. That will give me a negative 12x. And then you have negative 3 times positive 8. That would give me a negative 24. And that's all you do. Outside term times inside term, you're done. Here you have negative 2 times x, which is negative 2x. And on this one, you have negative 2 times negative 10. Well, negative times a negative is a positive, so you want to write plus 20 because 2 times 10 is 20. Make sure you look at this as a negative and that is a negative, okay? Okay, now on 4, I got to use the distributive property twice. Let's just focus on this part right here. So let's do negative 4 times x is negative 4x. And then we'll do negative 4 times 5. Negative 4 times positive 5 is negative. That will give me negative 20. Okay, so I got that part out of the way. Now let's multiply again over here. Let's use the distributive property. Again, the distributive property is what again? Multiplication. So let's multiply again. 3 times 5x is a positive 15x. If I say positive 15, I got to write that plus right there, okay? And then you have a positive 3 times a positive 2, which is just a positive 6. So I'll put plus 6. Now you should notice something after you multiply. How many people notice they have some like terms after you multiply? Okay? You do, you have some. So I'm going to split this up so you can see them. Negative 4x is like positive 15x. Now, if you're going back to like terms, it's same positive, same signs, you add and keep the sign. Different signs, subtract, take the sign of the larger number. So that's negative and that's positive. So they're different. So I'm going to subtract. 15 minus 4 is 11. And it's more positive. So it's going to be positive 11x. And then I have two constants. I have negative 20 and positive 6. Those are my two constants of regular numbers. So that's negative and that's positive. So what do I do if they're different signs? Well, you subtract. 20 minus 6 is 14. But you got more negatives than positives, so put negative 14. So the answer is negative 11x minus 14 in simplified form. Because you had some like terms, you got to take those like terms and combine them to make the answer as short as possible. Okay, make sure you have that written down because I'm about to erase it. So pause the video if you need to and write it down. I'm going to practice one more of these problems like number 5. Number 5, you got to multiply here, and you're going to have to multiply here. Now be careful when you get to this one. When you get to the second one, don't look at this as 7 times this. You got to look at it as -7. So catch, the sign has to go with it. The sign in front of the 7 has to go with it. So what is the sign in front of the 7? Negative. So you look at it like that, okay? So I'm going to multiply here first. So that's going to be 10 times x is 10x. And then I have 10 times -7. Positive 10 times -7. Leaves me with a negative. That's going to be -70. All right, now I'm going to multiply on that second one. Okay, so I'm going to multiply here. Remember to catch the sign in front. So don't look at it as 7 times 2x. Look at it as -7 times 2x. -7 times 2. -7 times a positive 2 leaves me with a negative. That's going to be -14x. And then we're going to look at this as -7 times -5. A negative times a negative is a positive. So I'm going to put plus, and 7 times 5 is 35, okay? Now, if you look at these, you should see some like terms. I hope you do. Really hope you do. Okay, so draw your bars to make this thing shorter. I'm going to combine 10x and -14x. 10 is positive. 14 is negative. Well, they're different, so I'm going to have to subtract. 14 minus 10 is 4. And it's more negatives. So I put -4x. Okay? And I also have some constants that are like -70 is like +35. That's negative and that's positive. So I'm going to subtract 70 minus 35. That's 6, 10, because you can't start off with 0 and take away 5. 6 minus 3 is 3, so that's 35. But in this case, again, it's more negatives than positives, so make that -35. So in simplified form, this answer is -4x minus 35. All right, we'll have 2 more, and then I'm going to let you work on the practice. You may have to work probably at home this weekend, okay, guys? All right, 1/2 times x is simply 1/2 x. Okay, I'm going to need you all to know how to be familiar with these. We've gone over multiplying fractions in our basic skills video. So this is 1/2 times -6. I'm going to have to put it over 1, so I can do top times top and bottom times bottom, okay? All right, so let's write this down. You got a positive, excuse me. Sorry about that, guys. You got a positive 1/2 and a -6/1. So I know my answer is going to be negative something. All right, so top times top gives me 6, and then bottom times bottom gives me 2. So my answer is -3. And that's that problem. Remember, when you're multiplying fractions, you need to do top times top and bottom times bottom. So here it's going to be 2/3. Hold on. See if you can do that problem on your own. Hello? Yeah. Okay, so I'm back. You have 2/3 times 12. You're going to put 12 over 1. So now you're going to do, and that's regular multiplication. Top times top gives me 24, and bottom times bottom gives me 3. 24 divided by 3 is 8, so I get 8x. Now you're going to do 2/3 times -9. All right, so you have 2/3 times -9, but put it over 1. So you can do top times top and bottom times bottom. So let me make sure I get my sign right. +2 times -9 leaves with a negative, so that's -18. And on the bottom, you get 3. And when you divide, you get -6. So I get 8x minus 6. And that's your answer. All right, guys, what you're going to do is you're going to go back to the classwork tab and work on your practice. And it's due on Monday. I will check it after the bell work, and then you'll have a comprehension quiz on this, okay? Thank you.